Welcome to further mathematics class. In this class, we'll be discussing dynamics. Alright, the lesson outline include point 1, Newton's laws of motion. Point 2, displacement. Point 3, acceleration, and point 4, velocity. Dynamics. Dynamics is a study of motion of bodies under given forces. The three important laws which relate to the motion of bodies under the action of these forces was given by Sir Isaac Newton. Now we'll talk about the laws of motion. First law. Every body continues in its state of rest or uniform motion in a straight line unless it is compelled to change that state by external impressed forces. The second law states that the rate of change of momentum of a body is proportional to the applied force and is in the direction of the force. Newton's third law. Newton's third law of motion states that action and reaction are equal and opposite. When two bodies are in contact, the forces of the action and reaction are equal in magnitude and opposite in direction. The equation of motion with uniform acceleration are v is equal to u plus at, v square is equal to u square plus 2as, s is equal to ut plus half at square, where u is equal to initial velocity, v is the final velocity, a is the acceleration due to gravity, s is the displacement, and t is time. Acceleration. If the velocity of a particle is changing, the rate of change of velocity with respect to time is called the acceleration. Acceleration is measured in meters per second square. Velocity. Velocity is the rate of change of displacement with respect to time. The rate of change of displacement with respect to time. Velocity is measured in meters per seconds. Displacement. Displacement is defined as the change in position of an object. It is defined as a change in position of an object. Displacement is a vector quantity and it has a magnitude and direction and is measured in meters. Mass and particle. The mass of a body is the amount of a matter contained in that body. The mass of a body is the amount of a matter contained in that body and is measured in kilogram. While any body whose dimension can be neglected is called a particle, linear momentum. The linear momentum of a particle is a product of mass of the particle and its velocity. Linear momentum of a particle is a product of the mass of the particle and its velocity. It is measured in kilogram meters per seconds and is written as rho is equal to mv. Example 1. A boy sits on a log. The mass of the log is 8 kg and the weight of the boy is 55 kg. What is the reaction of the ground on the log on which the boy is sitting? Take g, that is acceleration due to gravity, to be 9.8 meters per second. Solution. The mass of the log m is equal to 8 kg. The weight of the boy w is equal to 55 Newton. Acceleration is equal to 9.8 meters per second square. W, which is the weight, is equal to mg, and that gives us 78.4, and the total reaction now gives us 133.4 Newton. Example 2. A particle of mass 3 kg on a smooth surface is acted upon by a force F. If the acceleration produced in the particle is 2 meters per second square, find the magnitude of the force. I repeat the question. A particle of mass 3 kg on a smooth surface is acted upon by a force F. If the acceleration produced in the particle is 2 meters per second square, find the magnitude of the force. Solution. By Newton's second law of motion, force is equal to ma, that is mass multiplied by acceleration due to gravity. M is equal to 3 kg and A is equal to 2 meters per second square. Therefore, force is equal to 3 multiplied by 2, which is 6 Newton, or 6 kg meters per second. Example 3. A constant force P of magnitude 108 Newton is applied to a body of mass 10 kg. The first question is, find the acceleration produced in the body. And also, assuming the body starts from rest, what velocity does it attain after 6 seconds? Solution. Force P is equal to 108 Newton. Mass is equal to 10 kg. And recall that force is equal to ma, where a is acceleration. Therefore, substitute for mass in that equation. 10a is equal to 108. Therefore, acceleration is equal to 10.8 meters per second square. The second part of the question, assuming that the body starts from rest, what velocity does it attain after 6 seconds? Now let's consider that question. From rest, it means initial velocity is equal to 0. Recall from the equation of motion, v is equal to u plus at, when u is equal to 0 because it starts from rest, therefore v is equal to at. And don't forget that acceleration has been calculated, and that is 10.8 meters per second square multiplied by the time, which is 6, and the velocity is therefore 64.8 meters per second. Thank you.